question on solving this one. I think it was maybe number 3 in 7-2. So the first thing I want to do is get one side to 0, and I can bring this way or this way, it doesn't really matter. I think I'm going to bring things this way because I want to show this one step. And so if I add this over, that would be a plus 4w squared. If I add that over, it'll be a plus 5w, and that is greater than 0. So I'm going plus this over. I don't like that negative out front at all. That makes it harder to factor to me. So something I think a lot of people probably do is multiply both sides by -1 right there, just to get that sign cleaned up. And the thing that I wanted to remind everyone is when you do that with an inequality, that flips the direction of the inequality. So it's really easy to forget that little thing, and then it makes everything exactly backwards wrong. So that will make that a positive. That's going to make this one a negative, and that'll make that one a negative. And then instead of greater than, that's that flip. So now this is less than 0. So now we're all set to do our factoring. I'll grab the common factor out of there. So w out front, leaving w squared minus 4w minus 5. And then we'll factor this last bit, and w minus 5, and w plus 1. And so now we have zeros at w equals 0 for that one out front. If we set this equal to 0 and solve, we'd bring the 5 over, and that would give us w equals 5, and w equals -1. Same idea, set to 0 and solve over. So let's think about what that would look like on a number line. My number line is not going to be to scale because I want my number line to be clear. So I'm going to throw -1 right here. I'm going to put 0 kind of in the middle. And I'm going to put 5 right here. Again, not to scale. But what that helps me do is to see, so this is where all my zeros are. And what I need to do is, if I was going to do a sine chart or test points, I would pick points on these intervals to test. So if I wanted to do test points, for instance, if I picked -2 and I put that in here, this would be a negative times a negative times a negative, right? Because that'd be -2, -7, -1. So this right here would be a negative value. If I put -1/2 in there, that would be a negative, another negative, but now -1/2 plus 1 would be a positive, so I'd have 2 negatives and a positive, so this region would be positive. If I pick a number in between 0 and 5, I would pick 1 because it's easy, so 1 would be positive, 1 minus 5 would be negative, and 1 and 1 would be positive. So we have 1 positive, 1 negative, 1 positive. So that was a single negative, so that's a negative. And you can kind of see how it's alternating here. And likewise, if I put in 6, they're all going to be positive, and then that region there is going to be positive. What we wanted to find was where this thing is less than 0, so that's going to be the negative regions. So we would want this part for our answer, and we would want this part for our answer. And then there's no equals on here, so these are all going to be open dot. So this would make my solution -infinity up to -1, and then union that with 0 to 5. So that was one way to solve it, and that was my least favorite way of solving. So now I'm going to do a different version. Come down here, I'm just going to make a quick little graph of this. So I'll make this one slightly more to scale. So let's call that -1. And there's 0, we'll go 1, 2, 3, 4, 5. We'll call that one 5 out there. So if I think about what, let's see, right here at this stage, where it's all kind of cleaned up, it is a w cubed, and so it's going to be the graph is kind of that shape. And then down here, I can see everything is to the first, so at those intercepts, everything is going to cross. So if I do that, now I have this, this, and this. So what back here, this is saying is where is this graph less than 0? In other words, where is it under the x-axis? Where are these values negative? And the answer to that is all along here for these x values, this is negative. And then here it pops up, so that's a positive, so we'd want to skip that part. But then look in here, that graph is all below the axis again, so that's negative. We want that part. And then from here on, it's positive, right, because this goes on forever. If you look, it's the exact same interval I just found up here for those negatives. So it went from negative infinity up to -1. And then in terms of the endpoints, we want to use an open. Same thing here, pick up at 0 and go to 5. So the exact same thing. And then lastly, because you just can't have too many ways to do this, there's this thing called sine charts coming up. And so let me erase this graph and do this one the third way. And no one likes sine charts until the next section, because that's when they're really handy, is when these are, oops, that's an eraser, is when they're rationals rather than something that's easy to graph like a polynomial. So for a sine chart, we would have w minus 5, and w plus 1. Same exact number line as I have up here. And again, I'm going to make this one easy to read so I have space in between them to work and not worry about the scale. So w is 0 at 0. W minus 5 is 0 at 5. And w plus 1 is 0 at 1. And so that divides this number line up into these same 4 regions that we saw up here. And then let me do this. I'm just going to kind of make this feel more like the columns and rows that it is. Okay, so if we have that, let's say I test -2, so something off of this interval, and this is -1 to infinity. So let's say I test -2 in here and then see what happens. So if I put a -2 in for that w, that is a negative. If I put -2 in here, that's negative. If I put -2 in here, that's negative. So that's the exact same thing I was doing over here when I was plugging in those -2's using test points. This time I'm just doing it visually. And then 3 negatives would make this region negative. Here, if I put in -1/2, this piece is negative. -1/2 would make this piece negative. -1/2 would make this piece a positive. So 2 positives and a negative make a positive. Same result I found there. And I picked -1/2 because it's a number between -1 and 0. Between 0 and 5, I can pick any number. I'll just pick 1 again, but if I put in a 1 for w, it's 1. If I put in a 1 here, it's -4. Oops, it's 1. Good, Derek. Okay, that makes positive. If I put in a 1 here, it makes a -4, so that is negative. 1 here would make a 2, and so that is positive. 2 positives and a negative. There's that negative region again. And then lastly, if I put in, say, 6, it would be positive. 6 minus 5 would still be positive. 6 plus 1 is positive. So that region would be positive. So here we would say the same thing. We wanted the regions that were less than 0. And so that would be from right there. We'd skip that because it's positive. And right there. And same interval notation. I don't like test points just because I prefer having a picture, so I think we actually see this in 7.3. I like this when I'm doing the rationals in the next one. I think it's the easiest way to do it. But for this section, I actually like the one that I erased. For me, once you can graph these, that's a pretty straightforward way to do them. So hopefully that gives you a little more information on how to approach them.